In this demonstration, I will show how you can use cryptographic hardware from IPsec to reduce power consumption when you are using an IPsec or SSL connection on a mobile device. To measure this, I'm going to use the Juno development board from ARM. The Juno board is a software development platform for ARM v8 based mobile application processors. There's an FPGA daughter board connected to the Juno board that is used to store the EIP197 mobile packet engine from inside Secure. This cryptographic accelerator is specifically designed to increase IPsec and SSL performance and reduce the power consumption. In our test lab, we have built a test bench to measure the power consumption of a mobile platform. In this setup, the Juno board functions as a VPN client. This device encrypts IPsec packets using ESP-AES SHA-1 transform and sends them to a VPN server. The Juno board has internal PVT monitors, and this allows me to measure the power consumption of the processor. With the DStream debugger, I can monitor the software execution inside the processor. First, I'll measure the power consumption when the Juno board is in idle mode. As you can see, the CPU load is almost 0%. And the CPU frequency is 450 MHz. This is the minimum frequency of the processor on this board. In this situation, the power consumption of the ARM processor is 57 mW for the A53 and 125 mW for the A57 processor. Now I'll measure the power consumption of the ARM processor on the Juno board when doing IPsec decryption completely in software, so without using the EIP197 packet engine hardware. We have chosen a transmission speed of roughly 100 megabit per second. In this case, the big core is used to execute the software and it uses 479 mW. The processor is fully loaded to do the encryption and the packet engine is not used. Now I will download the EIP197 packet engine in the FPGA and install the driver. I can see that the packet engine is accessible by reading out the revision number register. Let's start the test using the EIP197 hardware. Again, we transmit IPsec packets with a speed of 100 megabit per second. And as you can see now, the power consumption is only 176 mW for the little A53 core. This time, the big core is in idle mode and hardly using any power. To summarize, I've put the measurements that I've done in a table. It clearly shows that the power consumption when doing IPsec encryption in software is much higher than when using the EIP197 packet engine hardware. So, what is the conclusion? First, the EIP197 packet engine offloads the encryption task from the processor, making it available for other tasks. And secondly, we can say that the battery life of a mobile phone is significantly extended when using the EIP197 packet engine to do IPsec or SSL encryption.